how can I graph quadratic functions, identify the vertex, axis of symmetry, and the y-intercept? And we're also going to talk about the x-intercepts too. All right, so there's three forms of a quadratic function. We're going to start with standard form. That's going to be your most common form that you will see and use. In standard form, it looks like y equals ax squared plus bx plus c, where a, b, and c are just numbers, okay? They are any number that goes into the coefficients in front of the x terms and then a constant at the end. They could even be a 0, which would eliminate that term in that quadratic function. A can't be a 0 because then you really don't have a quadratic function, just part of that there. Now, a couple little things. If a is greater than 0, if it's positive, you're going to have a curve that goes up on your graph for your parabola. It'll kind of open up. If a is negative, it opens down. So that's an important thing to know about a. Now, c, basically imagine if x was 0, that would give you the y-intercept, and all you'd be left with is c, so c is your y-intercept. That's the point, that c is the y-coordinate for where the parabola will cross the y-axis. Now you have over here, a and b can be used to figure out the axis of symmetry. If you do negative b divided by 2a, and you'll see this negative b over 2a come to us later on, we'll talk about it in future lessons, but for now, this is the x value for the axis of symmetry. The axis of symmetry is going to be a vertical line, and it'll be x equals negative b over 2a. So whatever this value is, divided by 2 times this value, that'll give you the x value for the axis of symmetry, which is also the x value for where the vertex is. So you can use the axis of symmetry to figure out the vertex. So how do we do that? Let's kind of work through an example here. In this quadratic equation, we have y equals 2x squared plus 3x minus 6. Your a value is 2, your b value is 3, and your c value is negative 6. So my y-intercept would be down here at negative 6. My axis of symmetry is going to be at negative 3/4. So I come over here and I go, here's 1. So my axis of symmetry comes down here, right? And then we have a is 2, b is 3. I already figured this out beforehand. So we know our parabola is going to be something, it's going to open down here somewhere and go like this. We got to figure out where does it open, right? We also would have to figure out where it crosses the x-axis. So one way to figure out where its vertex is, it's going to be somewhere along this line, and it's going to open up because we have a positive a value. You would do negative 3/4 and replace x with negative 3/4 and solve the equation. That is one way to do it. I am not going to do that in the video. You could substitute in negative 3/4 for x and solve the equation. However, there's other forms that can help us figure that out as well. These other forms are the factored form. In the factored form, your quadratic looks something like this. Y equals ax plus c times bx plus d, where a, c, b, and d are just numbers. Now, these are not necessarily the same a, b, and c that you've seen in the standard form, so just keep that in mind. You could multiply this out and then simplify it to get into standard form. The reason factored form is great is because the roots, the x-intercepts, are going to be when y is 0. So you can basically change y to 0, and then when you ask yourself, this factor times this factor equals 0, well, that means one of the factors has to equal 0. So you set each individual factor equal to 0, and you solve for x. I'm going to show you how to do that in a minute. Vertex form. In this one, I intentionally changed it so it says y equals a times x minus h squared plus k. Keep in mind that h is being subtracted, but the reason this form is great is because it tells you the vertex. H comma k. So just keep in mind h is being subtracted. So x minus h. So if it says x plus, that's really minus a negative, which means your x coordinate for your vertex would be negative. Let's look at some examples and figure out those key things. So in standard form, we have here's a quadratic, 3x squared minus 16x plus 5. This helps us find, standard form is great to find the y-intercept. Your y-intercept is going to equal 5. There we go, done. All right. I'm going to do factored intercept form. So in this one, factor/intercept form, it gives us the roots or the x-intercepts. You can use those terms somewhat interchangeably. Y equals 3 times x minus 2 times x plus 5. 3 does not equal 0, so one of these two factors would have to equal 0 in order for y to equal 0. I've set them equal to 0 right here, and I will solve that in a second. And that will give me the two spots where the graph will cross the x-axis if they exist. Sometimes they don't. Vertex form, y equals x minus 4 squared minus 25. So in this case, we can see x minus h, so it is a minus, so that means it's actually going to be positive 4, comma, and then it's minus 25. That's supposed to be added, so it does mean negative 25. So minus 4 comma negative 25 would be the vertex of this quadratic equation. Now let's do the factored form. And in here we have x minus 2 equals 0. You just add 2 to both sides. So x equals 2 would be one of the x-intercepts. The other one would be subtract 5 from both sides. And you get x equals negative 5. So on this graph here, you'd have one here at negative 5 and one here at 2. And depending on the rest of the equation, your parabola might look something like this. And it would go like that. Okay, so that's how you would do that. You would get all this information from a quadratic equation, you'd plot those points, and you'd just draw a curved line connecting all those points together, looking something like that. We'll do some more practice in class.